functions in all three forms and investigating how to convert between the three forms. To convert the quadratic function f at x equals negative 2 times x plus 4 times x minus 2 into standard form, it requires the use of algebra. So the easiest way to do this, though, because it doesn't matter whether we multiply a times b times c or b times a times c, we still get the same answer. I always choose to deal with the two brackets first, the two binomials. So I'm going to distribute this x into the x minus 2, and then I'm going to distribute this positive 4 with the x minus 2. And notice I use big brackets because at the end of it, I've got to multiply it all by 2. So again, I'm going to use the distributive property here, x times x and x times negative 2 is x squared minus 2x. And positive 4 times x and positive 4 times negative 2 gives me plus 4x minus 8. And I've got negative 2 times x squared. I look for my like terms. Negative 2x plus 4x gives me positive 2x minus 8. And I distribute the negative 2 in, negative 2x squared minus 4x plus 16. And of course, I've got it nicely typed up here for you, so you don't have to try and copy the chicken scratch that I have on the last page from using the Mobi. Now, if I want to convert this into vertex form, I need to complete the square. So again, I need to pull this negative 2 out of the x squared term and the minus 4x term. So when I divide negative 2x squared by negative 2, I end up with x squared. And when I divide negative 4x by negative 2, I end up with positive 2x. And now I have to complete the square. And remember, that means I have to take the number in front of x and divide it by 2 and square it. And once I add that value on, I have to subtract it off to keep the equation balanced. Notice that while I did this, the 16 stayed outside because, of course, that's part of my k value or my maximum or my y coordinate of my vertex. So when I simplify, I end up with this equation. But only these first three terms are part of my perfect square trinomial. So I need to distribute that negative 2 to the negative 1 to bring it out of the bracket. Now I'm left with a perfect square trinomial, and I square root x squared, and I square root 1, and I keep the sign from here. So I end up with negative 2 times x plus 1 squared. Negative 2 times negative 1 gives me positive 2, and I can add the positive 2 and positive 16. And I now have the equation in vertex form. Last one I wanted to move around, I'm going to expand this one into standard form. And again, I need to use the distributive property. It's a little bit different though because it's a perfect square and I already know the shortcut. Oops, sorry, I grabbed the highlighter. I square the x, I square the 1, so that's x squared plus 1, and the middle term should be 2 times x times 1, so plus 2x. Now I need to distribute the negative 2 with each term in the trinomial. So I get negative 2x squared minus 4x minus 2 plus 18. And I can simplify. Last one, we're going to convert one quadratic function into factored form. Now the first thing we have to talk about with factoring is, what do we do first? We always common factor first. So that's the first thing. If I look, they've all got a negative 2 in common. Because of course I want to be left with a positive x squared, so I need to make sure I keep the negative 2 out of the polynomial in the bracket. At this point in time, I have 3 terms. I have 3 choices for factoring when I have 3 terms. I can look for a perfect square trinomial, which I can see doesn't happen because I need 2 positive perfect squares, and I don't have that. And then I look for a simple or a complex trinomial. Since the coefficient of x squared is a 1, I know I have a simple trinomial. So what I'm looking for is 2 numbers that have a product. Oh, I know why it's going crooked. Sorry, I couldn't figure out why the Mobi was drawing everything crooked for me. I had it sitting on an angle. It didn't like that apparently. So I need 2 numbers that have a product of negative 8 and a sum of positive 2. So remember our numbers. We start with 1 and 8 because 1 times 8 equals 2. They have to multiply to be a negative, So one of them must be negative, but since they add to be a positive, the bigger number must be positive. Now, if I go up one from 1, I'm at 2, and 2 times 4 works, and again, the smaller number needs to be negative. If I go up, 3 doesn't go into 8, 4 I've already got. So if one of these numbers doesn't give me a sum of 2, then I would say it's not factorable, but it does, so I can simply write negative 2 times x plus 4 times x minus 2. And before class tomorrow, exercise 4, page 8, number 1 to 5.